Roots and radicals, adding and subtracting. So how do you add or subtract roots and radicals? Well, you simplify each term first. Remember, terms are separated by pluses or minuses. If you need help simplifying roots and radicals, then watch the Roots and Radicals Simplify video, because that is covered in that video. Identify like terms. Okay, so simplify each term, identify like terms, and then add or subtract like terms. Right, the same way you do with numbers. If the signs are the same, you add and keep the sign. If the signs are different, you subtract and take the sign a little larger. Right? So what are like terms of roots and radicals? Well, the same thing you already know. All the variables outside the root or radical and their respective powers must be the same. This is the same thing for polynomials. If you have x squared y, then another term has to be x squared y to be like it. So if you have x squared y cubed and x squared y to the fourth, those powers aren't the same on the y, so they're not like terms. Same thing goes here. But in addition to that, the radicands, that's what's underneath the root of the radical, they must be the same as well, exactly the same. So if you have the square root of 2x, your other square root better be 2x. If it's not, those things can't be alike no matter what's outside the radical. Okay? But the variables outside the radical, all to the same respective powers, and what's under the radical has to be identical, or it's not a like term. Okay? So here's my disclaimer on these roots and radicals videos for many of them. For the purposes of this video, I'm going to assume all variables represent positive values. Please understand that variables can be negative, so if your book or class does not restrict these variables to positive, then you need to remember that square root of a squared is the absolute value of a, okay, for any a. Oops, wrong button. This is actually true for any even root of a variable resulting in an odd power. If you need more information on negative values of variables that are possible, then watch my Roots and Radicals Negative Variables video, all right? So for this video, we're going to assume they mean positive, so we don't have to worry about that absolute value of a there. First of all, we need to know, are these things like terms? We're not going to simplify these things or add or subtract them. I just want to know, are these two terms like? If they're like terms, then that means I can add or subtract them. If they're not like, then I cannot. So when I look at this, I don't have any variables, so then my radicals have to be the same. Are those the same radical? No. So are these like terms? Nope. Because those two things there are not the same, okay? Those two things there are not the same. So now I'm just going to move to the right here and go from left to right on each row. So here, x squared y and x squared y squared. So x squared is the same. That's okay. That's okay. Oops, check mark, check mark. Y and y, those are not the same. So it doesn't matter that, we never got to the fact that those are the same. These are not like because the y and the y squared are not the same. So these are not like terms, okay? And that's because of this. They're not like because of that. So what about the next one? Here, I don't have any variables outside the radical here, so square root of 8x. Same thing here, square root of 8x. Those are like terms because of this and this. They are like terms. Yes, they are like terms, okay? So what about the one to the right of it? Well, here we have an x and then a square root of 2x. We have an x. Those things are okay, right? But square root of 2x and square root of 3x. Wait a minute. That and that. That's why it's no good, okay? So this, like terms, no, because of this and this, okay? So if we want to go back, this and this are why they're not like terms. This and this are why they're not like terms. What about there's just one on the bottom here, isn't there? 3x to the fifth, y to the fourth. So x is to the fifth and y is to the fourth. X to the fifth, y to the fourth. Those are good, right? Then the square root of 2xy squared, not square root, 2xy squared is all in there. But the root's what? The third root, the cube root. I said it wrong, okay? So the cube root of this and the cube root of this are all the same. So guess what? Everything's the same. This whole piece here and this whole piece here, the only part with variables and radicals. So those two things are the same, so that's why they are like terms here, okay? That's why they are like terms, all right? So now that we know what like terms are and how to identify like terms, now we need to move on to adding and subtracting these, all right? So 7 square roots of 5 plus 2 square roots of 5. Are these like terms? Yes. So we need to add these together. So 7 square root of 5 plus 2 square root of 5 is 7 plus 2 is 9. And then we keep like terms like. I say this all the time. When you add like terms, you get a like term. When you subtract like terms, you get a like term. Or I may say when you add or subtract like terms, you get a like term. Or when you combine like terms, you get a like term. So my like term part was this. So then that's got to be in my answer. Okay? Look at the next one. 8 times the 4th root of 7 minus 3 times the 4th root of 7. Those are like terms. So in my answer, I have the 4th root of 7 unless the answer is 0, because 0 times anything is 0. But 8 minus 3 is what? 5. So 5, and then the 4th root, 5 4th roots of 7. All right? So let's look here. We have 11 square root of 13 minus 3 square root of 23 minus 8 square root of 13 plus 2 square roots of 23. So this term is like this term, right? Because of the square root of 13. So I can put those two things together. So then this and this go together, and I'm going to have a square root of 13, and I'm going to have 11 minus 8, which is 3 of them, right? 3 of them. And then square root of 23, I'm going to underline that twice just because it's different than 13, right? So those two terms go together. So I'm going to have a square root of 23, and I have a minus 3 and a plus 2, which is minus 1 of them. Minus 1 of them, all right? So 3 square roots of 13 minus the square root of 23. So those two terms cannot be combined because they're not alike, but I could combine different like terms in my original expression, all right? So let's look at the next one here. Square root of 7 plus the square root of 28. Are those like terms? They are not in the way that they are now. Can I simplify them? Well, look, I didn't say this on this page here, but you couldn't simplify any of these. There was no perfect square that divided into any of these right here, or perfect fourth power for that 7 there. So you couldn't do anything to those to simplify them. Here, though, however, 7 cannot be simplified under the radical, but how can I break 28 up? 28 is 4 times 7, and why do I pick 4 times 7? Because the square root of 4 is 2, and then so that comes out as a 2, and that's the square root of 7, and then in front of that is the square root of 7. So that expression equals square root of 7 plus 2 square roots of 7. Now, guess what? These two things are alike, and my answer's got a square root of 7 in it, and I have 1 plus 2. And what's 1 plus 2? 3. So that's 3 square roots of 7. So that one, we were able to combine the terms, but we had to simplify the square root of 28 first. So if I look at this one, 6 square roots of 12 minus the square root of 75. Square root of 12 and square root of 75 are not like terms. However, can I break either one of them up? Well, look, this is 4 times 3, right? So here's where I need to be careful. I have a what out front already? A 6. And if I bring the 4 out, what's the relationship between the 6 and this radical here? It's multiplied. So when I bring the 4 out, the square root of 4 is 2, and I need to multiply it by the 6 that's out front. And then what stays under my radical? The 3. So the 6 comes down. The square root of 4 is 2, and it gets multiplied by the 6 out front, and then square root of 3. So this term becomes 12 square root of 3. So I'm going to change colors for my next term. Do all that in that blue. Even though I did multiple steps, that's that term. Over here, can I break 75 up? Well, isn't 25 a perfect square, and 25 times 3 is 75? So then minus, and the 25 comes out as a what? A 5, and what stays under the radical? 3. So this is minus 5 square roots of 3. So now I have like terms. My answer is going to have a square root of 3 in it. It's going to be 12 minus 5, which is 7. And then 5 cube roots of 81 plus the cube root of 24. Again, those are not like terms in the form they're in now, but can I break 81 up? And this time I don't want perfect squares. I want perfect cubes. So 2 cubed is 8. Does 8 go into 81? No. So what about 3? 3 cubed is 27. So this is going to be 27 times 3. Is that what that is? So what is the cube root of 27? So the 5 stays out front. And then the 27 under the radical comes out as a 3, right? The cube root of 27 is 3. And then under the cube root, this 3 stays there. You cannot apply the cube root to 3 because it's not a perfect cube. So let's go ahead and finish this term in blue. 5 times 3 is 15. And then cube roots of 3. And then for this term, 24, 8 does go into it. 8 times 3 is 24. What is the cube root of 8? We have plus. The cube root of 8 is 2. I don't need parentheses. There's nothing out front with that. And then the cube root of the 3 stays under the radical. You cannot simplify that term anymore, so just bring it down. And then you have to decide, do I have like terms or not? Well, I have cube root of 3 and cube root of 3. So guess what? I have like terms, cube root of 3. And I have 15 plus 2 is 17 of them. So 17 cube roots of 3. 17 cube roots of 3. That's my final answer there. And then we look at this one, 4 times the square root of 45y minus 3 square root of 20y. Again, they're not like terms to start with. So can I simplify 45? And then also, can I bring any y's out? Well, for the y's, this 2 is here and the 1 is smaller. You can't bring any y's out. Same thing over here. So let's just focus on the numbers. So 45, the biggest perfect square is 9. In fact, that's the only perfect square that goes into 45, I believe. So 9 times 5. The square root of 9 is what? 3. So that's going to come out front. Under the square root, the 5 stays, right? And the y cannot come out either because it doesn't have a power, at least 2. And the 4 stays out front. So 4 times 3 times the square root of 5y, which simplifies to 12 square roots of 5y, right? That gets multiplied together. And then what stays out front here? The minus 3, right? And then break this up into 4 times 5. Why didn't I pick 2 and 10? Because you can't take the square root of 2 or 10. I picked 4 and 5 because I can take the square root of 4 and get what? 2. If I apply the square root of 4, I get 2. And then under the radical, the what? Is the 5, and then the y also stays under there with the 5. And again, I can multiply these together. Negative 3 times 2 is negative 6 square roots of 5y. And now I determine, do I have like terms or not? Square root of 5y, square root of 5y. So guess what? My answer is going to have square root of square root of 5y. And then 12 minus 6 is 6. So 6 square roots of 5y. All right? 6 square roots of 5y is our final answer there. So each one of those was simplifying a radical, but we had to simplify each one separate. 9 times 5 is 45. 4 times 5 is 20. They both were left with 5y under the radical. If one had been 5y and one had been 6y, we couldn't have put those together. But they're the same thing, so we could combine those like terms. All right, so here, again, they're not like to start with. So can I break 20 up? Anytime you see the square root of 20, it's going to be 4 times 5. The 8 stays out front. The 4 comes out as a what? 2. The square root of 4 is 2. And then the 5 stays under a radical, 5. And then can I bring x to the third out? Well, this is 2. So how many times does 2 go into 3? Remember I told you that in another video I told you here, pretend like it's a mixed number. 3 over 2 is 1 1/2. Here's the 1 that comes out, and here's the 1 left over, the 1/2. Okay? So that 5, 1x comes out, 2 goes into 3 once with 1 left over. Okay? So then plus, wait a minute. I want to finish this term. 8 times 2x is what? 16x times the square root of 5x. And then the next term, can I simplify this term? Is there anything in here I can bring out? No. The 5 won't simplify to a perfect square. The x, there's no power bigger than 2. So this is plus the square root of 5x. So we just bring that down. And then we say, okay, can I add these together? Well, I have x square root of 5x and just the square root of 5x. Because I don't have this x here, those are not like terms. So that is your final answer. You cannot put those together. Okay? Those are not like terms. Now, I have seen books and teachers factor out the square root of 5x and put 16x plus 1. Look, if your teacher wants you to do something like that, you do that. This answer, to me, is simplified. It's there. 16x square root of 5x plus square root of 5x for my students. But again, if your teacher requires something else, by all means, do what they wish for you to do. All right, and then the last one here. We have 3x and then the square root of 48x to the third, y to the fifth. So can I break 48 up? If you remember, 4 times 12 is 48, but bigger than that on perfect squares is 16. 16 times 3 is 48, and the square root of 16 is 4. So what's out front? The 3x. Then the square root of 16 is going to be 4, and then what goes, wait a minute, I may have more stuff, right? I got x's and y's. I may have more stuff that goes there, all right? And when I glance at the powers, they're bigger. I know I am, all right? Under the radical, I have a 3. What about x to the third? 2 goes into 3. We've already seen that one time. That's the 1 that's here, and then 1 left over. And what about y to the 5th? 2 goes into 5 twice, so that's the y squared with 1 left over, okay? And then if I finish this term out, this is going to be 12x squared y squared times the square root of 3xy. So now let's use blue to finish out this other term over here. So out front, it's going to be plus 2y squared. And 27, why do I pick 9 times 3? Because 9 is a perfect square. The square root of 9 is 3. And then, wait a minute. Again, I have stuff here that may come out. So I need to be careful here and say, okay, this stuff here, square root of 3. And x to the 5th, how many x's can come out? 2. 2 x's can come out with 1 left over. Can any y's come out? Nope, no y's can come out because 2 is not, or 1's not as big as 2. So y doesn't come out. Y stays under the radical. So I have extra space right here, but that's okay. All right. So now finish this term. That's going to be plus 6x squared y squared. I just wrote it in alphabetical order. You could put y squared, x squared. It's the same thing. And the square root of, you understand that the order it multiplies in doesn't matter, times the square root of 3xy. So do I have like terms right here? Well, x squared y squared square root of 3xy, x squared y squared square root of 3xy. So then x squared y squared square root of 3xy. Okay? So then 12 plus 6 is how many? 18. So I have 18 x squared y squared square root of 3xy. So I hope this has helped you with adding and subtracting roots and radicals. The big idea is to simplify each term and then look for like terms. And you got to be able to recognize what a like term is, okay, for these. All right?